This video is one of a collection on how to name ionic compounds. And in order to be ready for this video, you'll want to have checked out the ones on ionic compound formulas and finding ion charges. We're going to focus this conversation on fixed charge metals. So when you're naming fixed charge ionic compounds, you name the metal first, the nonmetal second, you replace the ending of the name of the nonmetal with "-ide", and if there's a polyatomic ion, just name it using its name without any changes. Now, that's nice, but what the heck is a fixed charge metal? Let's go ahead, whoops. This video is one in a series on how to work with ionic compounds, both figuring out their names and figuring out their formulas. If you haven't watched the supporting videos on ionic compound formulas and you're not super comfortable figuring out the charge of an ion, you'll want to check out those videos first. There are some rules for naming fixed charge ionic compounds. Before we go over those, let's remember our periodic table and talk about who the fixed charge metals are. So when you think about the periodic table, there's these two columns that are far to the left. And then there's a bunch of columns in here. There's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's 6 columns. 1, 2, 3, 4, 5, oops, 6 here. These first two columns on our periodic table, the alkali metals and the alkaline earth metals, are fixed charge metals. In addition, silver hangs out in here. Silver is always +1. And aluminum hangs out over here, and aluminum is often +3. So those first two columns of the periodic table, and then silver and aluminum, are what we consider our fixed charge metals. There are other fixed charge metals that show up in the transition metals. I'm not going to hold you accountable for knowing them, but you may run across a couple maybe in your homework where the charge isn't provided, but you can look it up elsewhere. So when you're writing the name of an ionic compound, you actually already have some experience doing this because you're probably familiar with this compound. It's sodium chloride. Notice we named the name of the metal first, sodium, and then we named the nonmetal, but we didn't name it chlorine. We took the ending of the name and replaced it with "-ide", and we called it chloride. And that's the name of NaCl. If there was a polyatomic ion present in here, let's say I had NaNO3, I don't have to adjust its name at all. I just name it. So I would name my element first, which was sodium, and then I would name my polyatomic ion using its name, which this is nitrate. So I would just call it sodium nitrate. Those anions and their names sometimes aren't readily apparent for students, so I've listed them here so you can see all of them at once and become familiar with them. Spelling does count when you're naming ionic compounds, well, really compounds of any sort, so being able to spell these correctly is important. So let's go ahead and name the following compounds, and I have some strange text thing going on in here. Just ignore it. So I've got CaS. So I'm going to name the first element, which is calcium, and then I'm going to name the second element and add an "-ide" ending. So this becomes sulfide. Down here on the second example, I have strontium, and then bromide. Notice I don't have to put anything in the name telling me that there are 2 bromines, because of the rules for naming, or the rules for ionic compound formulas, and because we have the periodic table, which tells us that strontium is always a +2 and bromine is always a -1. So if we were given strontium bromide, we would always come up with SrBr2 because that's the only combination that fits the rules.